In this video, we will evaluate this limit. So if you know what to do, you learned that in the past, you can pause the video, solve this, and then resume to the video to see how I do it. Before we start, I want to review an important concept. So let's say it's not really an important concept, it's just a basic algebra. So let's say I have a x plus y minus z, right? I have this in one quantity. I want to multiply the whole thing by 1/2. What is that equal to? So that equals to x divided by 2 plus y divided by 2 minus z divided by 2, right? We will need this concept in this section. Other than that, I want to try one more. So let's say I have x to the third divided by x squared. What is that equal to? That equals to x to the 3 minus 2. That equals to x to the first, right? What if I have x to the second divided by x to the fifth? So that will be x2 minus 5 equals to x to the negative 3. That is 1 divided by x to the third, right? And then let's say I have the square root of x to the 6. What is that equal to? So square root is the same as 1/2 power, right? So in this case, I have 6 multiply 1/2, we have a 3. So we will be using this simple algebra in this section. So let's start with the first problem. So first problem is A, we have limit as x approaches to infinity, and then the function, we have x to the fourth minus 3x squared plus x divided by x to the third minus x plus 2. Okay, so this is what we are going to do. I know that you are looking at a 4th degree, the 3rd degree. The first thing that comes into your mind is factor, but that is not the case in this section. So what the key strategy is, you have to find the biggest degree in the denominator, which is a 3. And then you have to multiply 1 divided by x to the third, 1 divided by x to the third. Do we care the biggest degree on top? The answer is no, we don't. Every time you solve this type of limit, find the biggest degree in the denominator. And then we have to divide each term by x raised to that biggest degree. So go back to the problem. So we have limit. I want you to start with a limit in every single line unless you get to the last step, all right? So we take it. What we are trying to do is we take each term divided by x to the third. So we have x to the fourth divided by x to the third minus 3x squared divided by x to the third plus x divided by x to the third, x to the third divided by itself minus x divided by x to the third plus 2 divided by x to the third. So we take each term divided by x to the third, and then you clean up the power for me. So we have limit as x approaches to infinity. This is a x, right? And then 2 minus 3 is 1. So we have 3 divided by x. I do not want to see negative exponent. That is not going to help the next step. Plus 1 divided by x squared divided by, this is a 1 minus 1 divided by x squared plus 2 divided by x to the third. And then what happens when x approaches to infinity? As x approaches to infinity, do you see those fractions? You have infinity in here, 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 and there. So what happens when you take a number divided by infinity? It's 0. So when you take a number divided by infinity, they will just approach to 0. So you have infinity minus 0 plus 0 divided by 1 minus infinity plus 0. So you have infinity divided by 1, that is equals to infinity. So as x approaches to infinity, y approaches to infinity. So this one, as x approaches to infinity, y approaches to infinity. So there is no horizontal asymptote. So let me go back to this problem again. Why do we need to divide every single term by x to the third? Not x to the fourth, not x to the 1,000. Because when we have x to the third divided by itself, this is the thing that I truly want in the whole process. I am trying to protect the denominator. If you divide each term by x to the fourth, so let's say you put a 4 right here, then that gives you a 1 divided by x in here. If you have that, big trouble, because you will have a 0 in the denominator. So overall, the reason of dividing each term by x to the biggest degree raised to the biggest degree of the denominator is I want to protect the denominator from having a 0 in the denominator. I do not want a 0 in the denominator. That's why. Let's take a look at the next problem. So we are in part B. Let's switch color for that. So in part B, oh, not the highlighter, right? The pen. So in part B, we have limit as x approaches to infinity. We have the square root of x plus x squared divided by 2x minus x squared. So this one, what do you need me to do? We need to multiply the top and bottom by 1 over x squared. Why? Because the biggest degree in the denominator is 2. If that is not a 2, if that is a 10, then you divide each term by x raised to the 10. The reason of doing this is I want to get a 1 in the denominator. Alright? I don't want to have a 0. So you go ahead, do the math. So x approaches to infinity. So this will be square root of x divided by x squared plus x squared divided by x squared. This is just a coincidence. I don't care what kind of exponent you have on top. So 2x divided by x squared and then plus x squared divided by x squared. Okay, so and then the next step, limit as x approaches to infinity, we have 1/2 minus 2. So 1/2 minus 2, we have 1 divided by x to the 3/2. It's okay, fraction is fine, plus 1 equals to 0 anyway. And then 2 divided by x plus 1. So as x goes really, really big, what do we have? We have 1 divided by infinity, that's a 0, plus 1, and then this is a 0, plus 1. So basically we have 0 plus 1 divided by 0 plus 1, that is equal to what? That is equal to 1. Again, look, the biggest degree of the top is 2, the biggest degree of the denominator is 2. So what do we have? The leading coefficient, the horizontal asymptote is the coefficient of the top divided by the coefficient of the bottom. So 1 divided by 1, we have a 1. So this is my horizontal asymptote, is y equals to 1. Oh, actually, let me fix that really quick. This is a minus, right? So this is a minus, this is a minus, this is a minus, this is a minus. So that will be a -1. All right, quick fix. Okay, moving on to more complicated problem, C. So C, you have a lot of work to do. So C, we have limit as x approaches to infinity. We have 2x squared plus 1, the whole thing square, divided by x minus 1 square times x squared plus x. Okay, this one, there is no easier way to go. You have fully open the denominator. So that is a limit as x approaches to infinity. We have 4x to the 4 plus 4x squared plus 1. And then you have to square the x squared, x minus 1 square. Then you have x squared minus 2x plus 1. And then this one, we are not touching that yet. And then you open this up. So you have limit as x approaches to infinity. I will just give you what that equals to. X to the 4th. Actually, maybe not. I will just open it up for you. So we have x squared times x squared, and then x squared times x. That is x to the 3rd, and then minus 2x to the 3rd minus 2x squared plus x squared plus x. Okay, you multiply all of them, and then the top is 4x to the 4th plus 4x squared plus 1. Now, I have to get the biggest degree on top and bottom. So this one will be, actually, let me say this again. I need to get the biggest degree of the denominator. But in the meantime, if you check out the degree of top and bottom, they are all 4, right? So the exponent of the top and bottom are the same. So therefore, the horizontal asymptote is really the leading coefficient of the top divided by the leading coefficient of the bottom. So I already know that this will be equal to 4. I don't need to do the rest of the work. So let's do the rest, because you have to show your work to earn credits, right? So you have limit as x approaches to infinity. The top is 4x to the 4 plus 4x squared plus 1. And then the bottom is x to the 4th. I can simplify the third power. So that is a minus x to the third minus x squared, negative 2 plus 1, and then plus x. Now I need to do some work on this. How do I have to divide each term by what? I have to divide each term by 1 over x to the 4th. So this is 1 over x to the 4th. Because the biggest degree in the denominator, again, I don't care the top, is 4. So once you divide every term by 4th power, what do you have? So this is limit as x approaches to infinity. You have 4x to the 4th divided by x to the 4 plus 4x squared divided by x to the 4 plus 1 divided by x to the 4. I know it's a lot to write, but as you get more practice, you can skip this step if you like. Minus x to the third, x to the 4th, and then let me just quickly write this down for you. Minus x squared, x to the 4th, plus x divided by x to the 4th. So which one of these will go to 0? Let's simplify. Limit x approaches to 0, so that is a 4 plus 4 divided by x squared, that goes to a 0. And then this one is a little mistake, so that is 1 divided by x to the 4th, that goes to 0 too. And then the denominator, 1 minus 1 over x minus x divided by x squared plus 1 divided by x to the third. So all the fractions become 0 once x goes to infinity. So we have limit as x approaches to infinity. Do we still need that? No, let's take that away. So when you plug in infinity, we have 4 plus 4 divided by infinity, 1 divided by infinity, 1 minus 1 over infinity. This one, did I simplify all the way? Yep. So this is supposed to be a 1 then. So this is 1 over infinity minus 1 over infinity. So all the fractions become 0. Then you have 4 divided by 1 equals to 4. So your horizontal asymptote is y is equal to 4. Just like what we said at the very beginning. So looking at the biggest degree of the top and bottom and then make a comparison, that is what you learned back in algebra. And then in calculus, we can use limit to find the horizontal asymptote. Moving on to D. So in part D, we have the limit as x approaches to infinity, the square root of 1 plus 4x to the 6th divided by 2 minus x to the third. Do we care the top? No, we don't care the top at all. The highest degree is 3, so we are going to divide each term by x to the third. Now, there is one little technique right there. The technique is the x to the third is equal to the square root of x to the 6th. Because when you multiply two quantities with an absolute value in it, so let's say the square root of 5 times 2, this one will just give you 2 square root of 5. You cannot multiply the square root of 2. You cannot multiply 2 and 5 unless they are both wrapped by a square root. So we have root 5 times root 2. This one you can multiply the 2 and 5. So that gives you a square root of 10. So that's why we have to rewrite it. So after we rewrite that, we can take the x to the third in inside this, inside the radical. So this is 2 divided by x to the third minus x to the third divided by itself. Look, the top becomes 1 divided by, after you take it in, that will be x to the 6. So x to the 6 plus 4x6. This is a x to the 6. Okay, it's no longer a 3. Because you take the square root of x to the 6, you get a 3. Because x to the 6 raised to a 1/2 is equal to x to the third. And then you have limit as x approaches to infinity. You have the square root 1 over x to the 6 plus 4 divided by, 4 divided by 1. All right, then that is a 4. 2 over x to the third minus 1. So as x goes to infinity, so you have the square root of 1 over infinity plus 4 divided by 2 over infinity minus 1. So this will be a square root of 4 divided by -1. So you have a -2. Then what is this? This is y equals to -2. That is my horizontal asymptote. So that is part D. Let's do E. E, we change to another color. So let's use white. So part E, we have a limit as x approaches to infinity, the square root of 9x squared plus x minus 3x. Ooh. This time you don't even have a denominator. What do? If you plug in infinity, you have the square root of infinity minus infinity. So which is infinity minus infinity? That is not equal to 0. It's not equal to 0. Infinity minus infinity. You cannot determine this. There is no way to determine the infinity minus infinity. No way. It's not equal to 0. Why? Because infinity is a very large value, right? It is not an exact value. It is a quantity that is extremely large. Which one is bigger, this one or that one? You don't know. All right, you don't know. Then why do you say that is equal to 0? You cannot assume they are equal. Although they look, the two symbols, they are identical. They look the same. But the quantity, the value, they are not equal. So that is not equal to 0. Then what do we have to do? We have to multiply a conjugate, right? So we have to multiply this. I don't want to override that. So we multiply 9x squared plus x plus 3x. Again, conjugate. Conjugate is we take the opposite sign. And then the denominator, we multiply the same thing, 2 plus x, and then plus 3x. Okay, so once you multiply, what do you get? So the top, you have limit as x approaches to infinity. You have 9x squared plus x, and then minus 9x squared, divided by the conjugate, right? And then you get rid of the 9x squared. Okay, did we solve the problem? If you plug in infinity, you will have infinity divided by infinity. This one, you don't know. They are indeterminate form. See, infinity minus infinity, we don't know what it is. Infinity divided by infinity, we also don't know what it is. So because of that, what is the biggest degree of the denominator? You might say, okay, easy, that is equals to 2, but that is not the case. It is the square root of x squared. The 2 is inside a square. So the biggest degree of the bottom is actually x, not x squared. So this, you have to multiply the top and bottom by 1 divided by x squared. And then limit as x approaches to infinity, we have what do we have? I said x. Why do I put x squared in there? It's x, not x squared. So we have 1, and then this one we bring bring the x in and change that to a square. So we have a 9x squared divided by x squared plus x divided by x squared, and then plus 3x divided by x. Okay, what do we get? We have a 9 plus 1 over x. Okay, I don't need to make the radical that big. And then plus 3. Okay, once x goes to infinity, then we have 1 divided by the square root of 9 plus 0 plus 3. So we have a 1 over 6. So the horizontal asymptote is y equals to 1 over 6. So that is for part E. Moving on to part F. So part F. How many indeterminate form did we cover so far? Number 1 is infinity minus infinity. We don't know what it is. And then number 2 is infinity divided by infinity. We don't know what it is. Okay, keep this in mind. You just don't know, right? We don't know what it is. Okay, part F, we have limit as x approaches to infinity, 1 minus e to the x divided by 1 plus 2e to the x. Oh, what's the highest degree? Oh, you don't even know it, right? So in this case, you have to divide the top and bottom by 1 over e to the x, 1 over e to the x, because I want to get rid of this 1 over e to the x. So this one, you have limit as x approaches to infinity, 1 divided by e to the x minus e to the x divided by itself, and then 1 divided by e to the x plus 2e to the x divided by e to the x. And then 1 divided by e to the x minus 1, and then 1 divided by e to the x plus 2. Okay, now as x approaches to infinity, we have e to the infinity, right? What is that equal to? Let's draw a graph. So the graph of the exponential function looks like this, right? So as x approaches to infinity, y approaches to infinity. So this one is just an infinity. Imagine this, you have 2.7 raised to a very large power. So that is equals to infinity, right? So we have 1 divided by infinity minus 1, 1 divided by infinity plus 2. So overall, we have negative 1/2. So my horizontal asymptote is y is equals to negative 1/2. All right, so far so good. Okay, so let's move on then. So next one, what color should I use? Let's use orange. So part G, we have a cosine. So limit as x approaches to infinity, we have e to the negative 2x cosine x. So every time you see a sine or a cosine in the function, what do? You use a squeeze theorem, right? Because for cosine x, this is the graph of cosine, is bouncing between 1 and negative 1. So as x goes to infinity, cosine of infinity, I cannot determine this. All right, I have to use something else to help me to determine cosine. So I just said that cosine is between negative 1 and 1, right? That is the range of cosine x. And then according to the problem, you have to multiply each side by e to the negative 2x. So that is negative e to the negative 2x, e to the negative 2x cosine x less than or equal to e to the negative 2x times 1. And then you look for the limit. So we have limit as x approaches to infinity, negative e to the negative 2x. So that is equal to limit as x approaches to infinity, 2x. So you have an infinity, right, in the power. So negative 1 divided by e to the infinity is just a 0. Same thing on the other side. So limit as x approaches to infinity past the e to the negative 2x that is also equal to 0. So we have the limit is sandwiched between two 0. Okay, so we have a 0 less than or equal to limit as x approaches to infinity. Copy the problem one more time, that is less than or equal to 0. So what number is sandwiched between two 0? The answer is 0. So we just found the limit. So my horizontal asymptote is y equals to 0. Surviving, right? We do the next one. Okay, which color should I pick? Let's pick a red. So part H, we have limit as x approaches to infinity. We have ln 1 plus x squared minus ln 1 plus x. I picked this problem is because I want you to review the properties of limit. Remember this, ln a plus ln b, you add 2 ln, that is equals to ln of a times b. If you have ln a minus ln b, you subtract 2 ln, that is ln a divided by b. So this one is a minus, so we have a limit as x approaches to infinity. We have 1 plus x squared divided by 1 plus x. I'm going to leave some space for some job. What is the highest degree? The highest degree is 1, right? So inside the parenthesis, we will multiply 1 over x and 1 over x. So that means we are dividing each term by x. And then we have limit as x approaches to infinity. Okay, 1 divided by x squared divided by x is 1, right? X is just x. And then 1 divided by x divided by x is 1. So as x approaches to infinity, oh, I totally forgot the ln. As x approaches to infinity, we have ln 1 over infinity plus infinity, and then 1 over infinity plus 1. So overall, we have ln infinity divided by 1, which is ln infinity. What is the graph of ln? The graph of ln is you have a intercept at 1, 0, and then ln is an increasing function. And then this is a vertical asymptote at x equals to 0, but we are not looking at the x the x equals to 0. So as x approaches to infinity, this side y approaches to what? Y approaches to infinity, right? So in this case, do you say that this is a horizontal asymptote? In this case, we say that there is no horizontal asymptote, because as x approaches to infinity, y approaches to infinity is not approaching to any number. So there is no horizontal asymptote. So we have 2 problems left. So let's take a look at the next one. The next one is arctangent. Arctangent means inverse tangent. I picked this problem is because I want you to review the graph of arctangent. So we have limit as x approaches to infinity. We have arctangent of e to the x. First of all, e to the x is, we have the graph, right? So e to the infinity is just infinity. So that means we have limit x approaches to, oh, actually we don't need the limit anymore. Let's erase the limit. So we erase the limit. So we plug in infinity. It is okay to just plug it in. So we have arctangent infinity, because e to the infinity is infinity. You see this graph, right? As x goes really big, y goes really big. But what about arctangent of infinity? I gave you a graph on my notes, but let's draw the graph. Don't just take it from my notes. So here is the graph of arctangent. Arctangent is between pi over 2 and negative pi over 2. So there are 2 horizontal asymptotes in the arctangent. The graph looks like this. I am looking at positive infinity, right? I am looking at this side. So as x approaches to positive infinity, y approaches to pi over 2. So y equals to pi over 2 is my horizontal asymptote. So that is the last limit. The very last problem, I didn't give you a limit. I gave you a function and then I asked you to give me the horizontal asymptote and vertical asymptote. So let's go ahead and do that really quick. So the last problem J, I have y equals to 2x squared plus x minus 1 divided by x squared plus x minus 2. So to find the vertical asymptote, first you have to factor the rational function. So that is 2x minus 1 times x plus 1. Use any factor technique you like. And then this is x plus 2 divided by x minus 1. Okay, for the vertical asymptote, okay, read this to yourself. Denominator cannot be equal to 0. Again, denominator cannot be equal to 0. So you have x plus 2 times x minus 1 cannot be equal to 0. So x cannot be equal to negative 2 and 1 because when x equals to either one of this, the function is undefined. So there are two vertical asymptotes. They are x equals to negative 2 and x equals to 1. What about horizontal asymptote? So horizontal asymptote, we don't take the factor form. I prefer to take what is given. So we have 2x squared plus x minus 1 divided by x squared plus x minus 2. So this I will just multiply the top and bottom by 1 over x squared. So that means we only need to consider this. So at the end of the day, what do we have? We only have the coefficient left, right? So we only have a 2 divided by 1 because what about the rest? The rest will be just x divided by 1 divided by x, 1 divided by x squared. So the rest will be just a fraction. There is an x in the denominator. So for all the fractions, they will just become a 0. So this is just equals to 2. So if you check the other side, x approaches to negative infinity of this function, you will get a 2 as well. So the horizontal asymptote is y equals to 2. So here is what the graph looks like. I'm not going to draw the graph for you. I will just set up the horizontal asymptote and vertical asymptote. So we have one horizontal asymptote at 2, y equals to 2. Again, that affects the right end and the left end only. That doesn't affect the middle. And then we have a negative 2. So that is my vertical asymptote. And a 1, that is my another vertical asymptote. Again, the horizontal asymptote only takes effect on the left end and right end. Everything in the middle will not be affected by the horizontal asymptote. So that will be all in this lesson. I catch you all in the next one. If you want, click the like and the subscribe for me. I greatly appreciate that. I see you in the next one.